How's everyone doing? I'm Dr. AJ Coomer, PhD. We're doing Euclid's Elements, Book 1, I guess Proposition 15. I've had just a rough... I'm trying to get my sleep schedule fixed. And, because, anyway, and, I took a nap last night. Or... I'm not sure when night is anymore, but I took a nap within the last 48 hours, and I woke up and I just had this horrible back pain, couldn't move. And anyway, I'm awake now, but I'm sedated. So, Euclid's Elements, Book 1, Proposition 15. If two straight lines cut one another, then they make the vertical angles equal to one another. Okay, vertical angles are congruent. That's literally like the one thing I remember from high school geometry. Vertical angles are congruent. So I think that's what this is vertical angles are congruent. Yep. So vertical angles are the angles that are on... Vertical means on opposite sides of the vertex, I think. Oh, I never thought about that, but yeah, that's what they mean. So let straight lines AB and CD cut one another at the point E. I say that the angle CEA equals the angle DEB, and the angle BEC equals the angle AED. Since the straight line AE stands on the straight line CD, making the angles CEA and AED, therefore the sum of the angles CEA and AED equals two right angles, right? That's what we just proved. Again, since the straight line DE stands on the straight line AB, so now instead of talking about this line standing on this line, we're talking about this line standing on this line. Since the straight line DE stands on the straight line AB, making the angles AED and DEB, therefore the sum of the angles AED and DEB equals two right angles, correct? Okay, and so are you going to... Right, he's going to do a subtraction argument, I bet, to remove this middle. Or at least my algebra brain goes right there. Right, so AEC plus AED equals AED plus DEB, therefore CEA equals... Right. But the sum of these... Right. AED was also proved equal to two right angles. Therefore, the sum of the angles CEA and AED equals the sum of the angles AED and DEB. Right, just what I said. Subtract the angle AED from each. Right, then the remaining angle CEA equals the remaining angle DEB. Right. And the argument is completely symmetrical. You can prove it for right, BEC and AED. Right. Therefore, if two straight lines cut one another, then they make the vertical angles equal to one another. Corollary. From this, it is manifest that if two straight lines cut one another, then they make the angles at the point of section equal to four right angles, right? Because you just add them. Because a straight line is two right angles, and then on the other side it'd be two more right angles. Although the term vertical angles is not defined in the list of definitions at the beginning of Book 1, its meaning is clear from its use in this proposition. Vertical angles are angles across a vertex that share lines as their sides. Is that... Okay. I mean... We're reading something that was originally written in Alexandrian Greek, I guess, and then translated through a game of telephone eventually into English, which is what we're reading right now. But anyway. A corollary that follows a proposition is a statement that immediately I know what a corollary is. It is possible that this and the other corollaries are interpolations inserted after Euclid wrote the elements. During the writing, he would have either bundled the corollary into the proposition or made it a separate proposition. Okay. Proclus is corollary. Proclus... I thought Proclus was BC. Okay. Proclus includes another corollary. If any number of straight lines intersect one another at one point, then the sum of all the angles so formed equals 4 rating, right? This proposition is used in the next one, a few others in this book, 2.10, 4.15 Clark University. Wow, they named one after Clark University. What? Oh, I see. It's 2 separate links. Where is Clark University, actually? I've never heard of that university. Who we are. Campus. Your website sucks. Campus and location. Where is it? New England. Oh, okay. Ugh. Anyway, that's all I have to say. I guess it's a short video and no GeoGebra. I'll see you in the next video. Goodbye.